360. All right, what are the 3 cube roots of I? Now we have our little formula down here that we can use that, let me scoot this screen down, there we go, r to the 1 over n. Now cube roots would be 1/3 power, okay? But the problem is that this formula is written for numbers that are in trigonometric form, and this number is not in trigonometric form. So what we can do is go ahead and rewrite this in trigonometric form first. Okay, so first we want to find out where we're located. Now, a number a plus bi, the x is this number here. We don't have one of those. Really what we have is 0 plus 1i is what we have here. So our x value is 0 and our y value is 1. Okay, so we go 0 and then up 1. This is where we're located. So our angle is a 90-degree angle. Okay, for r, remember to find your r, you do the square root of your first number squared, well that's a 0, plus that second number, the y squared, is 1. So we really get 0 plus 1, or the square root of 1, which is 1. Okay, so our r is 1, and our theta, which usually we use tangent to find it, but we can see clearly from our graph that we're at 90 degrees, okay, based on the fact that our x was 0 and our y was 1. So when we write I in trigonometric form, we have our r on the front was 1 times cosine of our angle, which was 90 degrees, plus I sine of our angle, 90 degrees. Now our number is in trigonometric form, and we can find the cube roots using our formula here. Now for our cube roots, they want all three of them. So we're going to calculate the first one, the second one, and the third one. For this formula, you notice you have k is 0, 1, 2. So for your first term, you start with k being 0 in the formula. The n in the formula is whatever type of root. We're doing the third or the cube roots. So in this case, our n's will all be 3's. Okay, they don't change as we find each one. The only thing that changes is k. So for our first root, we will have r to the 1/3 power, which our r is just 1, and 1 to the 3rd power is just 1. Okay, cosine of, we do the angle theta plus 360 times k. So our angle was 90 plus 360 times, again on this first one, your k is 0, divided by 3. Plus I sine of 90 plus 360 times 0 divided by 3. Okay, well, oops, I ran out of room here. Let me sit over here. 1 to the 1/3 power is just 1. Okay, for my angle here, I have the cosine of 90 plus 360 times 0 is just 0. So I have 90 divided by 3 is 30 degrees. Plus I sine 30 degrees. Now we know the values of cosine and sine of 30 degrees, so let's just go ahead and find those. The cosine of 30 degrees is root 3 over 2, and the sine of 30 degrees is 1/2. So the exact value of that first root is the square root of 3 over 2 plus 1/2 I. Let's find the second one. Okay, so this time our k is going to be 1, and when we get down here, our k will be 2. So we still have 1 to the 1/3 power. Cosine of, our angle was 90, but this time we have plus 360 times 1, divided by 3 still, plus I sine of that same angle, 90 plus 360 times 1, divided by 3. Well, 1 to the 3rd power is still 1, Then we have the cosine of 360 times 1 is 360. If we add 90 to that, we get 450, and divide by 3, we get 150 degrees for our angle. Again, this is one we know the exact values for. 150 is in the second quadrant, 30 degrees away from our x-axis. The exact values are the cosine of 150 is negative root 3 over 2. The sine of 150 is positive 1/2. So the exact value of our second root is negative root 3 over 2 plus 1/2 I. And then we're finding our third and final root. 1 to the 1/3 power still. Cosine of 90 plus 360 times 2 this time, all divided by 3, plus I sine the same thing, 90 plus 360 times 2 divided by 3. That looks a lot like a 2, but it is a 3. All right, 1 to the 1/3 power is 1. 360 times 2 is 720, plus 90 is 810, and then we divide by 3. So we did 360 times 2 plus 90 divided by 3, and that gives me 270 degrees. Again, 270 is an angle we know the exact values of. Okay, remember 270 is right there. The cosine of 270 degrees is 0. The sine of 270 is negative 1. So we have 0 plus negative 1I, which is just negative I. So we have found the 3 cubed roots of I. That gave us some surprising results, but it was root 3 over 2 plus 1/2 I, negative root 3 over 2 plus 1/2 I, and then negative I.